Hello and welcome to Chapter 18. In Chapter 18 we're going to be talking about cross-tabulated counts. In this chapter we're going to be going over types of samples, naturalistic and cohort samples, chi-square, test of association, test for Chen, case control samples, and match paired. Of course, this chapter is very long and goes in depth over a bunch of different topics. What we cover over in the PowerPoint here is what we'll be expected to know for the exam moving forward. Not everything in the chapter is necessary to know. We're just going to kind of go skim the top with some of this stuff. So starting off, last chapter, we introduced Chapter 17, but in the prior chapter, they considered categorical response variable with two possible outcomes. This chapter, we're going to be considering categorical variables with any number of possible outcomes. Specifically, we're going to go over different types of samples. So previously in the year, we learned that there was experimental and observational different type studies. Experimental is pretty straightforward as far as having some sort of experiment being implemented like through a pharmaceutical company with a control group, and we're measuring the difference between the groups. Well, now if we don't have an experimental design, it's more observational. There's many different types of studies out there, and so we're going to touch on some of them. The first three we touch on are naturalistic samples, which the book goes over talking about them being more of a cross-sectional type design. And the cross-classified is according to the explanatory variable and response variable. And then you have a purpose cohort samples. There's two different types of cohort designs. There's retrospective cohort designs and prospective cohort designs. And it's a fixed number of individuals selected according to the explanatory factor. And then we have case control samples, which is a fixed number of individuals selected according to the outcome variable. Case control, a great way to remember that one is like if you have a very specific type of disease, most often it's used for very rare diseases you don't see very often in the general public. You do a case control study for that, and if you think about case control, you're studying a very specific disease that you're looking at. So going into a little bit more examples about each one of these, you have a naturalistic example. So here we have investigators prospectively study 75 consecutive patients undergoing coronary atherectomy, which is a way to remove the plaque in your arteries for symptomatic coronary artery disease. Before the atherectomy was performed, blood levels of the anti-cytomegalovirus, it's a long word, antibodies were measured. 49 patients were seropositive for CMV. Seropositive is a nice fancy way to describe when people are positive, so it's a term also used in the HIV community. When someone goes from a negative status to a positive status, we call that seroconversion. So if someone is HIV positive, they're seropositive, and individuals who are not positive are seronegative. You can also get the term serodiscordant couples. A lot of times it's come up in HIV, and serodiscordant couples is when you have a partner who is positive and another partner who is negative, so they're serodiscordant. One is positive, one negative in the relationship. Moving on, so for this example, the subjects were then followed for 6 months after the atherectomy to determine the incidence of restenosis. If we make the simplifying assumption that the sample represents a simple random sample of like patients, we can view this as a naturalistic sample of n equals 75, in which n of 1 equals 49 are seropositive and n 2 are seronegative for CMV. All right, so this is a case, or not case control, I'm sorry, at the cross-sectional design. So think of cross-sectional as they're taking at a very particular moment, cross-sectional, just a snapshot at that moment in time and studying it. So here we have the purpose of cohort samples. And here we have a personal cohort sample. We examined the data from experimental cohort that was part of the NIH-sponsored Women's Health Initiative. This experiment cohort study involved 16,608 postmenopausal women. Roughly half of these women were assigned conjugated estrogen, and the remaining subjects, 8,102, received a placebo. Coronary heart disease, invasive breast cancer, and other adverse outcomes were monitored in the group on an ongoing basis. So cohort example, just think of this one as it's measured in time, and they follow people over time. It's a cohort, like much like in the School of Nursing, when you start the year off in the School of Nursing, that is your cohort, that is your group that is with you throughout the entire time. That's how we define cohort here in a study over time. So you can study a cohort at a specific time and move forward, or you can look at a cohort going back in time. That's a retrospective cohort. Here we have a case control example. So this one examines the relationship between male pattern baldness and myocardial infractions. Investigators studied 655 men admitted to a hospital for the first non-fatal myocardial infraction cases, and 722 admitted to the same hospital with non-cardiac diagnoses. These are the controls. In this case control sample, the investigators selected fixed number of subjects based on the status of the response variable, and the extent of the baldness was then assessed in the subjects using several methods. So here we have, see if we can X that out. Oh, it's not going to work. We'll go right back into it. Sorry about that. All right, so here we have naturalistic and cohort examples. Data from the naturalistic examples are shown in this 5x2 table. So here we have two columns. See column 1 here, column 2 here, and here's your rows. So it's always by row by column. Let us always put the explanatory variable in the row of such table. So here's your row for explanatory variable. And then the totals are tallied in the table margin. So at the very bottom here you have the total. This is the total of the column all the way down of column 1, and this is the total of column 2 all the way down. And here you have the row totals going across. And this is how you set up your table. We'll be going into more exactly how you set up tables as the presentation goes on, but for now we're going to just show and stop here. So other ways you can express the tables, you can show them through a histogram chart here. And here you have your rows and your columns displayed as histograms. And then you have conditional percents. It's the relationship between the row variable and the column variable is explored with conditional percents. There's two types of conditional percents, right? So there has to be two because we have a row percent and then a column percent, which is the cell count over the row total times 100 gives you your row percent. Column percent is the cell count over column total times 100% gives you your column percent. Row percents are used in cohort and naturalistic examples, described in prevalence and incidence, and column percents are used in case control samples. So here you have incidence and prevalence. Once again, incidence is the number of new cases that you'll see over a given time. So for HIV, we normally describe incidence as the number of new cases per year of HIV/AIDS that pop up. And prevalence is the total number of people living with a disease at that existing time. So if we wanted to know the incidence rate of HIV, we find out how many new individuals are diagnosed with HIV in that given year. The prevalence is the total number of people living with HIV/AIDS over the population at the time. So the top table here demonstrated by R by C table notation. So we have smoke and not smoke, group 1 to group R all the way in the bottom. For naturalistic and cohort samples, row percent in column 1 represents group incidence or prevalence. So here's our incidence and prevalence proportion. So here we have our p hat, which is denoted as proportion. So proportion of I is equal to AI over NI. So you would take, this would be like your AI over your NI. So if you had A of 1 over N1, and this is how you determine your, depending on how you're looking at incidence or prevalence rate in that area. So an example of this would be shown. So here we have a table represented by education level and smokers, either smoke or don't smoke. And you have on the side education group, high school, associate's degree, some college, undergraduate, graduate, college. So you have the number of total graduates. So here's your row. And you have 12 plus 38 is your total. And if you want to know the prevalence of smokers in that graduated high school, you would take your 12 divided by 50, and you get 0.2400, which is denoted here. The prevalence group or the proportion group, p hat of 1 equals A1 over N1, so 12 over 50 equals 0.24. And that is how you calculate the prevalence of the group. If you wanted to know the prevalence of like undergraduate degree program, you would take 32 divided by 271, and you would get 0.1181. So I'm going to stop the video here because now we're going to get into relative risk, and there's a lot to talk about relative risk. And I'm going to start